right. All right, dogs. Dogs. All right, dogs. I'm back because we are done. Dogs, we are done, but we are not finished. We wanna do the code that says, okay, what do we wanna do? Okay, I will tell you the story shortly, just to know what's up. Where are you going? I mean, you're so fast and furious and uh, you're okay. And so, all right, now we have an objective function that is negative. That leads to x less than 1 if we don't add the constraint. Why is the mouse like this? It's not good. Anyways, I hope it gets back. Okay, good. So x is less than 1. Once we only have obedience and PSD, now you're saying, oh, now IRIC wants us to have x greater than 1. So what will happen? It should be compute the problem right from the beginning again. This is the beauty of convex optimization. I want to explain it to you and myself for a second. So we have this is x, for example, and we have our convex or set, which is like the ellipse, and this is 1. Right now, for this objective function, our optimal solution is like here or here. I don't know exactly where, but then we have the constraint that we are not allowed to be on this side. So we need to be somewhere here. The optimal solution should be in this part. But we want to say that any solution, optimal solution, definitely have x1, not x greater than 1. You know why? Because this is the optimal. Let's assume this is the optimal. If we have any solution, like this blue point, I can connect blue to the red, and you know this function here on this line, on this interval, it is convex, right? And the maximum happens on the red point, and this is here. So you can also, like the x equal 1, bring it up here. This point definitely has a better value than this. So for any point in the in our feasible set, we have a better point, better value of objective with x equals 1. Therefore, we can say our solution lies on x equal 1. So what it means for us, it means that we don't have this. We need to, our elliptical inequality stays the same, no problem with that, but our Lagrangian stationarity constraint will change and we need to get updated. So x is 1. All right. What if x less than 1? Then x equals 1. Then let's take a look at our constraints. X is 1. So the only thing that is left is finding y, because sigma ij we can do the similar thing. What is going to happen with y? And I want to plot y, and I want to plot value of w. New objective, which is crazy objective. Crazy objective with x constraint and without. With and without x greater than 1 constraint, we want to see how the value changes. All right. which is the negative of welfare. I want to also say, so x is 1, let me add it here. These are gone, they are over. So our ellipse function should stay the same, but x is 1 in it. Our hyperbolic will change. And because, actually I just throw them away, but because we only have round sigma, our functions, because we don't have any term sigma ai aj times sigma ai theta I or sigma, any of these two sigmas are not multiplying by each other, it's separate, it's a quadratic form. Therefore I want to say actually round L round sigma ai aj actually won't change, because yeah, we don't have any term sigma ai aj times sigma ai theta I, so we will have eta a plus what is it? Lambda n minus 1 r minus 1 plus nu, the same thing, n minus 1 plus r equals 0. It is same. Then we have round L round sigma ai omega equals 0, which gives us s theta y. Did I have them here? I just have the formulas. What about here? No. Okay. So gives us s theta y plus s lambda. That's it. Plus s nu. The same equation doesn't change. Plus minus 2n nu sigma. What about s? No s. ai omega over sigma omega squared. This should be 0. And it gives us the same equation for y, which is eta y plus lambda. So our hyperbolic doesn't change much as well. Y lambda plus nu over 2n nu. This is the same thing. And x changes. We don't need x actually. X is 1. Perfect. And then we want to maximize. Sorry, x is 1. So we don't want to do round L round sigma ai theta I at all. And we just need to find the nu. What is nu? Everything is based on nu. And nu we know that is based on lambda. Nu is, we know what it is based on lambda. It is f minus r lambda minus eta a over 1 plus r. And lambda should be the same inequalities, eta a f minus r greater than this. And what else is left? Not much. So hyperbolic doesn't change much. So x is 1, the other ones do not change due to quadratic. If it was, we had term sigma ai theta I times sigma ai j or something more complicated, we couldn't say the same thing. So it's quite simple. And that's it. Let's go. Doesn't change. Now we have the inequality, which, by the way, it's super easy. Have the ellipse. Okay, our ellipse now is just an interval. There is no. This is just because we have. Like, what is our ellipse turning into? I will show you. What should I do? Oh, okay. So ellipse is x squared over length plus y squared over length is less than length, right? And in general, x minus x0 is squared plus y minus less than r. Now it's just y minus y0 less than r, which is an interval, and tells us what should be the sigma a omega, which is also just an endpoint. I don't think we will need to have the interior solution, but we can do it easily. I don't even want to compute those terms based on sigma ai theta equals 1 because it's nothing but mess. OneDrive, desktop, Python, research, Gaussian, benchmark, crazy, and let's go. If x less than 1. How can I make the two code look? So if I run this code and it gives me x less than 1, I need to do it again for the same value of r. Here we know all of the x's are less than 1, so let's separate them and then we can, because we need this code. Then we want to integrate this code with this one kernel. And this is actually pretty much the same thing. Well, we have a very simple case actually. So x will be 1. This bullshit, which was the most annoying thing. This was the most annoying thing, the most complicated equation. This is 1. Nu stays the same and return x and y. I will call it crazy hyperbolic. Actually, the value of y doesn't change. So y doesn't change and x is just 1. And crazy ellipse just need to change x is 1. Perfect. Ellipse, actually we can keep ellipse because x is 1. Even here, crazy hyperbolic is not a big change. We need to do the computation again, and I'm not sure about delta. Did ellipse gives us the delta? Okay, delta is something. And a equals max, I don't know, which is true, should be in a negative, and x and y are hyperbolic. Actually, yeah. Let me add crazy hyperbolic. The same thing. We are outside the interval. We want to get inside the interval, and these are the same. Why should our delta change? It should not change, right? What is the difference in delta? Delta is 0 if we are on the side of the interval. And when x is 1, we don't have any room for delta. Sorry, let me check. Let me look at this. Because it affects sigma I theta I, right? Yeah. So it's 0. If we are interior point, which means we are inside the interval, if we are at x, so we have this ellipse is like xy, right? We call it at x equals 1, so it gives us an interval. So we don't need to be at x0. And where is this epsilon term coming? Where is this delta coming? Delta is the slack of the inequality. Epsilon is the slack. Yeah, sigma I theta I. Let's see what happens here once we have sigma I theta I. Sigma I theta I is theta I times this motherfucker. We'll have this. These are independent. These are independent. I think that doesn't change. No, it doesn't change. Okay. And then I think we can say the same stuff, right? Crazy hyperbolic. One thing makes me worried is that actually it's not true. Yeah. Geometric is just for intuition. Dude, I have to go to the restroom. The thing is that we have a actually we don't use water here. I need to wash my hand. That's the tricky part. We're in a water shutdown. Crazy hyperbolic. Ellipse is less than 0. Means we are inside. We want to take the middle point. Done. I don't remember the computation of delta. But if x is positive, means that I have to go to the restroom. So let's do that. Stop it. I will go find a restaurant and I will be back. What is this one? So crazy hyperbolic xi, I guess these are all good stuff. X y y, and so what changes if y is not changing? Lambda is changing, and when we are outside the ellipse or inside the ellipse is changing. Oh no. I don't want to call them XX. Yeah, let's say I call it XX. Normal Well, XX fucking. The other one is sane. Crazy. What is the opposite of crazy? Oh, Chibo has a crazy. Sane. Crazy will be sane. Sane. Eh. Alright, crazy XX sane equals XX of YY sane equals YY. Why are we appending 0? Oh, okay. L sane. Okay, we don't want them, but let's plot them. Equals L DD same equals DD. Mean A should not change. That's it. And what else do we want? Yeah, I'm gonna run this part. Then I don't want to plug this part, but and then I want to say, let's see what we're plotting. I am getting rid of this stupid problem. Stupid problem. I want a problem that has application. Has application. Oh, by the way, okay. What is sigma AIAJ? Do I have a formula for sigma AIJ? Do I want sigma AIJ? No. Yeah, I want sigma AIJ because it gives me the value of the objective. Alright, what is it? One of the constraints is binding, and that one gives us sigma EIAJ, but I don't know which one. So I have to I think I had it before, it should not change. Okay, we have sigma EIAJ. EIAJ. This is it. Why is it this one? And then this one assumes there is no epsilon. Alright, let's see what sigma EIAJ here. Everyone has their own sigma EIAJ, right? By the way, sigma EIAJ. Sigma EIAJ. How can I compute sigma EIAJ? Oh, sorry, sigma EIAJ. Either it is this form or this form. Do they have the same sigma A squared, delta squared, sigma epsilon squared, which is 1. This is delta squared j less than I or j not equal I. How many I we have? So if it is I, it's 1 is n minus 1 times. They cancel each other. What the fuck is this? Yeah, what does that mean? It should be j less than I. If it is I not equal j, well, they just cancel each other. It is I less than j. So each term comes in. I mean, it will be 1 over n minus 1. The other one will be like 1 I forms always negative, right? So we have minus n minus 1 of them. So, I mean n minus 1 over n minus 1, which is 1 over n. 2 has 1 positive for 1 and n minus 2 negative. Will be n minus 3. What does this mean? I not equal j. So it's like epsilon 1. Well, epsilon 2 minus epsilon 1. Oh, fuck. The utility 1 minus 2, 2 minus 1. We have a formula for variance of A, right? Oh, shit. And I'm wondering how did we used to. Oh, okay. For them, we can do sigma A, j. So I compute it. If eta A is positive, first PSD binds. Okay. First PSD binds and n minus 1 r minus 1 is negative. So it's a equality. We have x and y, then we have sigma a aj. If eta a is negative, second PSD binds and we have sigma a aj. If eta a is 0, I will do it either positive or negative. No problem. So we can do the code here. I mean, where is if eta a is negative? Actually, it is also giving delta. Eta a is negative. We are second binding. Negative second PSD bind sigma AIJ. I have it here. Negative second PSD bind. What is the value? Jesus. There are x and y, right? If I take, even if I take sigma theta inside, nothing will change. 1 over bar theta. Where is it? 1 over bar theta times so 1 over n minus 1 times 1 plus r. That's it. That's the whole denominator, n minus 1, 1 plus r. Then we have numerator, which is numerator is numerator is 1 over var theta times something, sorry, actually something over var theta, something over var theta plus n over var omega times sigma ai omega squared, which is sigma ai omega is s var omega yeah, that would be nice too. S var omega, doesn't matter, times y, right? Is it true? Y is S var omega, exactly. It's sigma a omega, not S. This is squared and minus S squared var omega times y, but I have to find some room. That's actually nice. Oh no. Okay, what is this one? So something over var theta, right? Which I will add, plus n var omega over var omega s var omega y squared minus s squared, because s var omega y is n, and minus t squared var theta x, which is 1, and actually I like that we are keeping it x, and this is it. What about this one? Exactly. Okay. 1 plus r sigma ai theta I times sigma ai theta I will be t var theta x minus t so when it is 1, actually we know that it will be 1. Okay. Squared. All right. t squared. They will cancel out. So it gives us, I don't know, you completed what it gives us. Minus t, where is it? Var theta. Alright, over var theta. Over r. This whole thing over r. Fuck. So I say this is squared over r squared. This is squared over r squared over var theta plus n var omega over that done over n minus 1 plus r. This is it. Eta is greater than 0, second PST. If eta is negative, which one I wrote? If eta is negative, second PST is binding. So it will have 1 over n minus 1 r, 1 plus r. And 1 over, yeah, second. I wrote the second actually. Okay, I did good. 1 plus r sigma I theta I minus t var theta squared plus n var omega, which has the var omega term, the other one doesn't have it, minus s greater than minus t greater than and over d greater than. That's it, simple, right? And eta is greater than or equal 0. Eta is greater than 0, sigma aj is this. This time we will have, so we have minus s bar omega and minus t squared there. What we don't have is this sigma omega term, and this term also changes to var theta. Okay, let me just look at this. By the way, this one changes to n minus 1 r minus 1. Minus 1, which is not good. We need another. Perfect. And this one will be, we can say f minus, if I divide it by n minus 1 will be f minus r sigma I theta I minus t sigma theta I squared minus ft. Where is it? F. Do I have f here? I want to remove f minus r. It will be f minus r sigma I theta I, which is t var theta x, minus said f minus y. Minus ft minus f times t. Oh fuck, minus ft var theta rather than over squared over r squared over var theta. That's it. And then objective. Do we have the same shit here? Yeah, we should have the same shit here. Actually, we should. It's it's a less than 0. So if eta is less than 0, second place divides n minus 1, 1 plus 0. And what is the creativity in this fucking PhD? That's so stupid. This is a stupid, that's a waste of your life. Eta is positive. Perfect. And I think we have some indentation. No, we don't have. Okay. And is that it? Okay. Sigma aj. Objective chain is not true. Equals what was that? Eta A. But eta A is changing. So I have to change. Eta A is minus n minus 1. Okay, I can add objective here too. Objective, I wanna keep it lowercase. Objective equals eta A times Jesus. Now I have problem. Sigma A. So I'm not gonna object this. I thought we can do that, but I don't wanna do that. Unless I say sigma A, J, Z, Z. Fuck that. It's A equals minus n minus 1r. What is eta x? Minus 1? And what do we have here? Dude, honestly, if ChatGPT can do the same thing, just saves humanity. Honestly, I'm being wasted here. This is donkey work. Even donkeys are. See, it is bad for donkeys to do this kind of stuff. Nothing, no. Only ChatGPT deserves to do this kind of stuff. And alright, now we have R. We have everything. So we want to plot X and Y sane, and then Y crazy. Sine is x. No. X. Y is there's no rain. What is it? X squared bar theta. Where is it? What? This one is fixed. But the problem is here too. What? What? Dude, don't be so annoying. Who? Oh, actually, it should be same. It should be crazy. Which two doesn't? Oh, the same thing here. What is 0? Arc that size. That's 1500. The same. Why is it 0? Oh. Okay. Yes, we don't have interior point. So these are not, they should not be here. Where is where we say F eta A? Like delta, where we say what delta should be? Well, this is delta 0 for sure. Okay, here delta should be 0. But we also want to say dd is delta, but what is delta? Okay, we are saying delta here. So I need to add the same things. Mm-mm. So now it works, and then we should do the same here. It seems then we have a lot of interior points here. Perfecto. All right. Lace out down. So for that one, we know x is just always less than 1. But in general, I have to also fix that part. Drastic change, right? And you wanna say we don't have obj saying is that. What do you mean it's not defined? Oh, Actually, I'm so happy that in our optimal welfare and optimal revenue, we don't need to add. Actually, we get the x greater than 1 for free because blue curves are crazy. Do you see? Okay. And what else do I want to say is alright, I just shared them and maybe the code later. Where is it? Okay, Sigma AI Omega Theta. It doesn't look like the version we had, the green one. But there is no change in that code. Maybe it looks like, I don't know. Yeah, actually it looks like So let's see if I want to change it when x is negative. Yes, we are doing the same thing. Okay, editing the code is not very difficult for the crazy part. We just need to change this hyperbolic function to, like, at the hyperbolic we have la 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 based on f r lambda nu and r, and we return x. The rest of the thing are the same. Eta a, eta that does not change, and does not change. So I can say just maximum. I have one on the shed there. One and this is it. And just we are computing the maximum. I just added max of one on this, then everything else is crazy hyperbolic, and then we want to keep the rest the same. Let's do it one last time. Still we need to give the numbers eta a, eta change when change the. I cannot talk. Perfect. 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 And just this section is a bit tricky, but I don't mind it, to be honest. Just for future. Another counter. I hope this time it shoot. I got tired today, to be honest. Oh, I don't code anymore. I need to learn code with ChatGPT more. That's coding now. From now on, coding is learning to do ChatGPT. Coding. Wow, 3 knives. Fuck. Everybody likes pool. Yeah, of course. Is it gonna rain? Jesus. Yeah, it's gonna rain. Oh, I got it. Wow, I had one shot. He's killing all of them. Fuck me. Dude, M4 is so... That's terrible, okay. They are killing us. I mean, that sounds obvious, but they are badly hit. This fucking gun ain't helping. Oof, God, thanks. They're really good. Okay, change the style of the game. We are hiding here. We are waiting for you. Like this. Okay, my dogs are strong now. Oh, this motherfucker electric with Electra actually should lost my ability to talk. Wow. Dude, come on! How much does this gun have? Dude, don't hide. You feel the speed? Oh shit, I knifed him. I like shoots, Let's go shoot. Dude, nap is like 15 minutes, not 1 hour and a half. Maybe. Ah. Hey, it's just blood. No people. No people to kill. Jesus. Jesus. Oof. 3 of them. Oof! Dude, going backward doesn't solve your problem. Oh. Dude, their butt killed me. This time I killed him. Oof, I killed him. And this time I killed him. Oh Jesus. Who said you there? Alright, good to know. Pitch. Draco, you started the bad game. I need more ammo. And I need more ammo. I just want more ammo. Dude, where are you guys? Where are you going? Bitch. Dude, I got him on the head. Nice hit. Shot. 1 million. Oof. While jumping. Dude, even from close distance? What does he have? Oh, he has a good one. Draco, you is left behind. I was waiting for it. Bitch. Who's shooting at me? Uh-huh. Draco, got back to the game, motherfucker. Ha 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 ha. Dude, I had... Fuck you, Draco. I want his blood on my hand. Haha. Fuck you and all of your fucking script kid. How is that possible? Dude, this first skin is having this gun forever. What's going on? Oh, it's over. Draco is over, now it's the fourth skin. This time I killed you. This time I killed you. This time I killed you. This guy with the snipe killed himself on me. What's going on? Fuck you, loser. Killed him or not? Let's go baggage, guys. This was a good... Ah, come on. I'm not gonna play it. Fuck that.